Welcome to this new lesson. In this new lesson, we will generate embeddings for text and measuring similarities between these embeddings. So let's now go back to our controllers folder and create the controller. We will call it Semantic Search controller.js. Okay, in this file we'll start by importing the OpenAI configuration file which we created here, and it initialized an OpenAI object and make it available for us. Then let's define the main function in this controller. This function called generate embedding, it will take a text and return the embedding representation of this text. It is asynchronous because it will use the await word when we are making the call to the model. So let's actually go ahead and call the model. This is the OpenAI object which we required from OpenAI configuration. .create embedding, that will create embedding. It takes a JavaScript object which we will fill in now. It is preceded by await because it is asynchronous and it will take time, and it returns the response object. So the first entry of the JavaScript object is actually the model. We will use text-embedding-ada-002. And the second input is the actual text that we pass to embed. The response is from a create embedding function. It is an object that includes the embedding representation of this text. And for now, let's just console log the return. We have the return response object, data key. Data is an array, but we only selected one. And embedding is the actual vector returned. So let's now export this to be able to call it from outside. So now we have our generate embedding. Let's go to playground and make a call to it. So here we require this controller that we have just created, and we exported this generate embedding. Let's now have a text to embed. So I put text1 to be the boy playing in the street. And now I will just go ahead and call this generate embedding function. Of course, this function will call this method and should console log this. Let's try and test it. So I will do node playground. Okay, so as you can see, this is the returned vector. Of course, for this model, this vector is of size 1536 dimensions. 1536 dimensions. It printed 100 at the top, and the remaining are 1436. In fact, each dimension of these dimensions capture a certain aspect of this string. Okay, now let's go back to this controller. Now I will comment out this console log, and I will instead return the embedding. Now, to measure similarities between vectors for two different texts, we need some mathematical equations. We use what we call cosine similarity. Cosine similarity represents the angle between the two vectors or the two embeddings. If they are very close, the angle is very small, and so the cosine is very near 1. While if they are far from each other, so the angle between them is far, then the cosine will be closer to 0. Texts that are close to each other, that have small values or cosine similarity of 1, are contextually close, while texts that have a large angle between them and have a cosine closer to 0, then they are contextually are not close. So in order to measure the cosine similarity, we need to define the cosine similarity function. So this function does the dot product of the two vectors or the two embeddings and divide by the normalization. So we need to define these two functions, the dot product and the norm. So first, let's get the dot product. So this is the dot product. It's just doing a multiplication of two vectors of the same size. Sorry, that was the norm function. Now we get the dot product. So this is the dot product function which does a dot product between two vectors of the same size. Of course, it inverts the second one. Here is the norm, which calculates the square root of the distance between the two vectors. Of course, we don't want to care about these functions. Cosine similarity, there are lots of tools that are available already to calculate the cosine similarity. Yet in OpenAI API in the Node.js library, they still didn't add this cosine similarity function. So for now, we define it here. Later, I'm sure it will be available. And now let's this cosine similarity export it to make it available from outside. So this is for the changes in the controller. Let's go back to the playground now. Okay, so this generate embedding now returns the embedding, and because it is asynchronous, I need to add a then block. And inside this then block, I just do a console log. Now actually I will get the vector or the embedding of another text to be able to measure the cosine similarity between them. So let me add this new text. So this is text 2. You can see that text 1 and text 2 written very differently, but almost having the same meaning or the same context. So when the first embedding returns, I will actually do another embedding. So this will do another embedding for text 2, and I attached a then function because it is asynchronous, and this is the anonymous function that will be called with the new embedding. I will now log in this embedding that we got, and now I will just call the cosine similarity. This is the cosine similarity which we need to import it here now, and it takes embedding 1, embedding 2, and print the cosine similarity between them. How similar are these two embeddings? So here at the top, I will now import. So let's go ahead and run this. So it will make two calls. It will get the embedding 1 and embedding 2. And as you can see, the similarity is very high. It's close to 1, so they are very similar. That's because they contextually almost mean the same thing. Of course, they are written completely differently, but in terms of similarity, they are used in the same context, so they are similar. And that's the whole idea of semantic search. Okay, let's now try another sentence. So now I am making text 2 to say it is a wonderful morning, while text 1 is saying that kid is playing in the street. Let's now save and test these two vectors. As you can see, the similarity is much less. It is just 0.76. So text 2 now and text 1 are not used within the same context, and so semantically they are not close. That's for this lesson. We will in next lesson build a cache for the embeddings.